when I was quite young, maybe I was in class 5 or something, I used to ask my father, like, how do people who do PhDs know that no one else has thought about this thing? Like, there's so many people in the world and there's so many people studying. Like, how would I, like, anybody understand that what they're studying is unique to them? PhD sounds so special because this is your topic. I had no idea about anything at all. My father never took up science, but he used to do experiments like burning things and doing chemical experiments, which is very dangerous. So I was always like passionate about these things. But then in class 10th, I had to choose between biology and mathematics, and I loved both of them to my core. But then I had to make this choice, and I thought, oh, I want to challenge myself more because I found math slightly harder than I found biology. So I was like, okay, I'll just do math because I want to challenge myself.
Hello and welcome to Indian Diaspora Podcast. This is your host Rahul. Today's podcast is very special. It's about a student from India who is pursuing her PhD in Department of Theoretical Physics and Mathematical Institute in University of Oxford. That's a special journey of her. She comes from IIT Kanpur and has taken the road to University of Oxford in a field that is so exciting, the field of STEM and science. Nivedita, welcome to the Indian Diaspora Podcast.
Thanks, Rahul, for having me. Yeah, I'm very excited to have this conversation with you today.
Sure. So the field of mathematics and the field of theoretical physics and doing a DPhil or a PhD in this field, how did this unfold for you? How did this come about in your strategy
Um,
for career?
so I when I was quite young, maybe I was in class 5 or something, I used to ask my father. I had no idea about what I was most passionate about. Of course, every little girl wants to be an astronaut. But I used to ask my father, like, how do people who do PhDs know that no one else has thought about this thing? Like, there's so many people in the world and there's so many people studying. Like, how would I, like, anybody understand that what they're studying is unique to them? So even at that young of an age, I was like, oh my god, PhD sounds so special because this is your topic. I had no idea about anything at all. But so the way in India it works is like till class 10th I was obviously doing biology and physics, chemistry, mathematics. And I was always interested in science. I suppose it was always very exciting. My father used to tell me that he never took up science, but he used to do like experiments in his backyard, like collecting lenses and like burning things and doing chemical experiments, which is very dangerous. But so I was always like passionate about these things, and I would talk to my father about how everything is so exciting. um, but that in class 10th I had to choose between biology and mathematics, and I loved both of them to my core. Like, even today I just really love biology and neuroscience. But then I had to make this choice, and I thought, oh, I want to challenge myself more because I found math slightly harder than I found biology. So I was like, okay, I'll just do math because I want to challenge myself. And that's how, like, I started, like, my journey with maths. Of course it's hard because you always feel like you're not good enough for something. But this, as years progressed, I found like there is special kind place for everybody in mathematics, and there is a kind of maths that everyone will enjoy. We just are not exposed to it very early on. So yeah. So
Wow.
that's
Yeah.
yeah.
I mean, after IIT Kanpur, you could have gotten job into, a multinational, earning so much, but you decided to further head on into
Yeah.
science, and that to theoretical physics
Yeah.
and mathematics, right? Which is so special about your path in life. So
That,
let us understand actually your PhD um, area, if you will.
yeah,
Help
sure.
help us understand what are
So
you? specializing in theoretical physics and mathematics at Oxford?
So I'll first I want to actually stress that in India, so I of course gave the joint entrance exam, the JEE, which is sort of the rite of passage for everyone in some way, and I was enrolled in an engineering degree at IIT Kanpur. But I'm so grateful for how flexible the curriculum is, because I then, during this engineering degree, when I was also doing like experimental things, I had the freedom to choose courses in maths and physics, and those professors sort of shaped my entire research interest. So I would really like, I want to stress that it doesn't matter what your major is. As soon as you find something you feel very strongly about, you can sort of direct your energy and your focus to that. So I really like describing what the kind of mathematics I do. So I obviously come from more of a physics background, and physics was always quite hard for me. So the way it turns out is that so physicists are of course geniuses, and last century physicists came up with this thing called quantum field theory, which is supposed to be the theory of how particles interact, and it's this like really really beautiful theory. But it is lying on slightly shaky mathematical grounds. So they do something called path integrals, and these things are extremely creative, but they are not supported by rigorous mathematics. Like this thing blows up, like it's infinite somehow. And physicists know how to make sense of it, because intuitively they know what it should be. But there is like, at that time in last century, there wasn't mathematics to support it. Like we did not know how to make this precise. So the kind of mathematics I do is basically trying to define what quantum field theory should be mathematically, and what kind of theorems can we make about physics. So it's basically like mathematicians developing a toolbox that sort of supports physics and observations that physicists make and theories that physicists come up with, to make it more precise and make it sort of uh, yeah, make it, package it into really concrete mathematical terms. So that is the kind of mathematics I do.
Hmm. W- So, what's an unsolved area or unsubstantiated area in physics by mathematics that you want to embark on? I know this might be too early in your PhD, right? But what I
uh,
want to give to our audiences is that what are the mysteries out there, right? What is uncorroborated, unsubstantiated physical theorems or have
uh-huh.
hypotheses that need mathematical backing?
So I think if we had any physicists around and you would ask them what is quantum field theory, so they'll every physicist would come up with a different answer. It's how they see quantum field theory. It's how they use quantum field theory. So a condensed matter physicist who's like maybe making like quantum computers and working on like small semiconductor chips would have some understanding of what quantum field theory is. A high energy physicist talking about black holes and quantum gravity will tell you some other way they see quantum field theory. But what, as a mathematician, I'm trying to understand is like, can we really define this thing? Can we like axiomatize this thing? And this axiomatization started
What
back
does
in 19.
axiomatize mean?
Axiomatize means you give a set of axioms. So you give such certain data, and that satisfies certain structure, and then has certain properties. So you basically don't want to wave your hands and be like, oh, quantum field theories, this fields and they interact, and you want to mathematically say what it is.
Hmm,
Like give a precise definition. So that
hmm,
is one of the aims of life. And then similarly, very, very recently, so all of us know that symmetries of things, like we have reflection asymmetry, or if we take a cube, you can rotate it around, there are symmetries. And for the longest time, hundreds of years, we knew that these symmetries form a mathematical structure called a group. And
hmm,
even for physics, people used to study quantum field theory, and they had the quantum field theories, and they were studying the symmetries of these quantum field theories. So you would have different groups, which were symmetries of these quantum field theories, which were also symmetries of our space time. But it turns out that these symmetries have a much richer mathematical structure, which again is now formalized in the kind of mathematics I do. People usually call it higher mathematics because it has a lot more structure packed into it. So understanding symmetries of quantum field theories is another very open, broad area, which again, the kind of mathematics I do sort of plugs into and gives back to the physics community.
Fascinating, fascinating. What are the applications of
Um,
of
you
these?
should never ask a pure mathematician about
I love
applications.
that.
uh, but I think the application is, so. Of course, I can go down a slightly philosophical route down here. I can be like, what even is the point of doing pure maths? And I sometimes do ask myself, like, what will happen if I prove this theorem? Like, we're not going to make any groundbreaking discovery. I think it's just like this slow and gradual progress of like human knowledge in general. Like you collect everything you know, and then you add little bits, and then you give it to the next generation of mathematicians and physicists and scientists, or people who are exploring how the world is working, and then they add something, and then it progresses. So
Yeah,
more than like an immediate discovery, you're just trying to add to the understanding of how things work, and like unraveling more structure in the universe around us.
yeah.
So,
You just made me think there by your response. I'll begin on a lighter note. If you watch The Big Bang Theory,
yeah.
Sheldon, very, very proud theoretical physicist,
Yeah.
makes fun of all the engineers, right? Which is all about
Yes,
practical
exactly.
application. On the serious note, right? You just made me think. I come from the business world where
Hmm.
we all think about, the ROI, or companies think about quarterly profits, etc., right?
Yeah.
But science is so pure. It's in its own realm. Uh, who knows how the dots connect and what
Yeah.
elephant it makes out to be, once the
Exactly.
dots connect, right? And that's the pure
Exactly.
pleasure of pushing the boundaries in science.
Yeah.
Hmm. Wonderful. Wonderful.
It's really like you are just like putting pieces of a puzzle together and
Yeah.
hoping that one day it will all like
Yeah.
fit in, but you are just doing maybe your little corner. And yeah, it's just, and I think it actually makes a lot of pure mathematicians like wonder, like, am I contributing? And it's a very tricky thing. But then you can also contribute in ways which is like just telling people, making kids excited about maths, and like telling other people how you understand maths. And I think that is also somehow contributing to the
Yeah.
community in general. So
Hmm. Absolutely. Beyond this, techno jargon talk, right? Which,
yeah.
and I'm saying this for, let's say, non-physicists or non-science background might be a bit heavy, right? Let's
Yeah.
light our conversation down.
Hmm.
What are the mysteries of the universe, broadly speaking, or mysteries in physics that you are puzzled by, you wonder, that one day, on the point of connecting the dots, one day you hope to find an answer for?
Hmm. That's a very deep question. I think, well, I could go down I think, for example, for me, the biggest, well, for any physicist or any theoretical physicist, the biggest mystery is like making sense of quantum gravity. Like, we don't understand how quantum physics and gravity interact. But that's again too technical. Like, when I am working on day to day, people ask me, like, why do we live on a space time that is four dimensional? Like, we have these three dimensions of space, like up, down, left and right, and then we have the fourth dimension of time. Like, why only four? And then a string theorist will come and be like, no, 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 they're not four, there are more, and they're just compactified. So I think, and then people ask me, like, why do you think four is so special? Or like, will we ever find a theory of quantum gravity? I think these are all like really, really fascinating questions. But I want to be very honest, and I'll tell you that I do not deal with these questions day to day, because otherwise you'll just not be able to work. Like, if somebody's thinking like, oh my god, I'll just figure how quantum gravity works, that
Yeah.
then you're just, the question itself is so overwhelming that you can't do anything. So you have to pick your little piece of the puzzle and just work with it. So for me, if I understand how the problem in my PhD thesis, which is something to do with the special kind of quantum field theories called conformal field theories, work, like if I'm even not all of conformal field theories, maybe if I can put like a little piece in that, that will be like
Yeah.
my biggest um, sort of like short term achievement. So I think more than bigger, of course, like bigger questions excite us, and bigger questions like how are these different structures playing around and how are these things working together, they of course are extremely exciting. But when you're solving a problem, when you're trying to do uh, a small piece of the puzzle, then you usually do not think of these like grand scenarios, which I think is, yeah, it's important to remember that like a working theoretical physicist is not thinking of like solving the problem of quantum gravity. They're working on their little piece of puzzle, and that's it. Yeah.
Yeah. Yeah. Once again, another nugget of wisdom from you there, Nivedita.
uh,
Pick up your piece of puzzle and
yeah.
be at it. You don't
Yeah.
know what that might lead to or what dots it
Yeah.
might end up connecting.
Yeah.
I find this really wise. Gita says, our philosophy says, karmanyevadhikarastu ma phaleshu kadachanam. Keep on doing your karma, your
Mhm.
efforts. In this
Yeah.
case, is focus on a
You're
piece of puzzle, an area, and you don't know how you'll collaborate with another scientist and what that leads
exactly. Absolutely. Yeah.
leads
Like
to.
a completely
Hmm.
different branch of
Yeah.
mathematics might like relate to it, and then you
Yeah.
have these like really fruitful collaborations.
Mm.
Um, so yeah. Another
Okay.
thing I think I want to like sort of bring up is how when we were younger, some people are like, oh, I'm just not good with numbers. Oh, like these algebras like ABC variables floating around, what even is X? Like we always like introduced to mathematics in this very structured way, and in a lot of children, including me, were somehow like intimidated by certain things when we were
Yeah.
growing up. And I think there the role of teachers just becomes like extremely crucial, because mathematics really is not about numbers, not just about shapes, it's not just about algebraic quantities. It's really about like the underlying logic and the underlying reasoning of it all, which I think every human by default has. So what I am really passionate about is like making people not fear mathematics, because there definitely is a kind of math out there which you will absolutely love and you'd absolutely enjoy thinking about. It can be logic, it can be geometry, it can be like topology, or it can be like combinatorics. So there is a kind of maths that all of us sort of will find our heart connected to, which I think is very
Mm.
important, because people generally be like, oh, I just don't like maths. But have you like seen this kind of math where you can like play with shapes? Or have you seen this kind of maths which is just all about like solving puzzles and counting things? So I think this is very like important to me, that everyone feels that they are good at maths, and there is nothing
Mm.
like, oh my god, I'm not good at maths. Like everyone
Yeah.
is inherently like really we're just given that sort of reasoning and logical way of thinking. We just are sometimes not exposed to like how to channel it or how to make it more structured, but there
Mm.
is a kind of mathematics which all of us will enjoy.
Mm. We will explore that. There's a kind of mathematics that we can enjoy. But before that, let's understand the root cause. Why do you think some people fear mathematics?
I can try to go back to my childhood, and I think sometimes people fear abstraction. For example, I think I was in class 5 maybe, and I came back home and I asked my dad, because he was my only like, I did not have internet growing up, for example. So he was my only like source of like contact, for like probing for information. So I was like, Dad, do you know what integers are? And my father was like, no, I haven't heard of what integers are. And then so it was the first time I was introduced to the concept of negative numbers, like 1, 2, 3 are the natural numbers, and then there's like -1, -2. And I think at that point suddenly people are like, oh my god, what is this, what does this -1, -2? And I think so that like whenever we are introduced to a new concept, we have this like natural instinct of being scared of it because we
Hmm.
won't understand it. And I think at that time, if somebody sort of motivates what we are trying to do, then that helps. So like for negative numbers, you're like, oh, I can subtract natural numbers. So if I have 5 things and I subtract 3 things, I'll get 2 things. But what happens if I want to subtract 5 things from 0 things? Like we need to have a concept for this. So then you're like, oh, -5. So this is like an abstract thing. And early on, if we sort of make children okay with the idea of accepting abstract ideas, I think that really helps. So as long as people can accept, okay, I'm going to label this abstract idea which I don't fully understand, I'm just going to put this in a little black box and label it -5. And then you
Hmm.
start playing with these abstract concepts more and more, and then your understanding of it deepens more and more. So like even there are lots of maths out there which I find like I can't touch. But then I sort of put them in a little black box and try to understand, okay, what are these people trying to do with this thing, and how, what are its properties? And then you sort of feel more and more for it. And by the time, maybe in a couple of years, I don't know, you are then extremely comfortable with it. And then that just becomes the most natural thing for you. So
Hmm.
I think just the initial push of accepting something abstract is needed.
Yeah, good reflection. So abstraction might be the early fear.
Yeah,
Let's say, the concept is understood. 0 minus 5 is -5. Like, what is
yeah,
minus in the real world, right?
yeah,
So the brain has to, a young child, as he or she is learning math, has
yeah.
to absorb that concept and move on.
Exactly.
So let's say they move on, they've done their mathematics until, 10th standard or 12th standard before they head to engineering,
Yeah.
right? That's when, they start bifurcating into application.
Mhm.
But somewhere theoretical, the journey of theoretical math, leaves most of the students in India who, become pharmacists, or engineers or
Yeah.
biotech or MBA eventually, right?
Mhm.
Talk us to a journey beyond school grade mathematics to, I would say, mid level mathematics concepts, and then
Yeah.
higher mathematics. And then let's lead this discussion towards different kinds of mathematics, right? When you
Mhm.
say, hey, there are different kinds of mathematics that you might enjoy. And you also
Yeah.
said there's some mathematics kind that you would not touch. So let's
Yeah.
understand this broad sphere. How would you
Mhm.
categorize school level maths versus beyond? And how does
Mhm.
one know what category of mathematics is made for them?
You've absolutely nailed this question because you just said what category of mathematics. And the kind of mathematics that I do is actually called category theory, where different category so categories are really like categories of sets. You can have categories of other kinds of mathematical objects. So like category theory is the broad area of mathematics that helps us link different maths. Um, so starting from maybe like class 10th, class 11, class 12 in India, everyone's like preparing frantically for this joint entrance exams. I think even there you get sort of introduced to different you have algebras, you have differential equations, you have things that you sort of know whether you like something or not. But then that at that stage of life you are under too much pressure to sort of perform in these entrance exams, so you might or might not enjoy what you're learning, which I think was because during my J years I was also sort of preparing slightly outside the like J realm, where I got introduced to some kinds of maths which wasn't part of the J curriculum. So what I want to, so there are, I can like say there are three or four different kinds of things. So there is algebra. So we all would have seen some kind of algebra when we were growing up, where you have variables like a, b, c, x, and they behave in certain way. Or then there is number theory, which is all about like prime numbers and distributions of prime numbers. Then there is like combinatorics, which people who are good at chess or people who are good at uh, counting things or counting different ways things can happen. So there's that. There's probability theory. There is like analysis, like partial differential equations, like differential equations that govern how signals are processed. Then there is geometry, like the like understanding spaces and understanding how like different structures you can put on spaces. So there are all these different kinds of mathematics, and I think the rite of passage is that you do a couple of courses in all of them. You at least learn slightly about all of them, and then you will go to one lecture one day. For me it was like knot theory and topology, like just the mathematical study of knots. And that lecture sort of made me realize, okay, topology is the kind of mathematics I enjoy the most, doesn't scare me. And so I think you have to sort of try out everything before you find something that you really really enjoy. So yeah. And so category theory, coming back to your question, is this like so it started off maybe in 1945ish, which was like different. So as I said, there are like these different kinds of mathematics. There's algebra, there's geometry, there is topology. So category theory is kind of meta mathematics in a way that it links different areas of mathematics. So somebody who wants to study spaces, like geometric spaces, but study it via algebra. So this is like algebraic topology or algebraic geometry. So this kind of language helps you to relate different kinds of mathematical aspects. And physics, of course, is like the mother of all. Like physics is somehow the reason people started like finding these structures. So of course quantum field theory is again like there is geometry, like Einstein said, oh, space time, the geometry of space time is like everything in some way. So physicists are always taking this geometry as input and producing output as like measurements or like states and space. So this, like taking in geometry and outputting like numbers or algebraic quantities, is also captured by this thing, like this kind of mathematics, category theory. So, and this is the kind of things I enjoy doing. Like if someone asks me, oh, what is like even the tiniest of multiplication, like what is 47 times 36, I will not be able to do it. So I want to stress that even if you're not good with numbers, that does not mean you're not good at mathematics. Like mathematics is so much more. Like it's, you can, if you're good at imagining things in your head, if you're good at grasping abstract ideas, I think like there's a lot more to mathematics than just numbers. So yeah.
Good discussion here. There's much more to mathematics than numbers.
Yeah.
Go beyond your initial fear of abstraction.
Yeah,
Take different
exactly.
courses. Do you
Hmm.
like geometry, for example,
Yeah.
or do you like knot theory?
Yeah,
And apply, see what pulls you. And
exactly.
if I may say, don't think about application. You got to be good with imagination.
Yeah, you just have to feel like what would you like thinking about if you're like just given time to think, like what
Yeah,
gives you
yeah,
that kind of pleasure.
right. Now, I want to, add a different concept here
Mm-hmm,
to this discussion. The work by Daniel Kahneman of Thinking Fast and Slow of Cognitive Biases.
mm-hmm.
Daniel Kahneman said there are two kinds of minds. One is system one, and second
Yeah.
is system two. System one is
Mm-hmm.
basically, the patterns one has seen in life,
Yeah.
uh, and that stores sort of in the frontal lobe of your brain. And
Mm-hmm.
system two is anything that needs calculation,
Yeah.
right? Anything that needs analysis. So that
Mm-hmm.
means either interpreting a chart, or if you ask me here, Rahul, what's 345 cross 642?
Yeah.
Now, I don't know about others, but I drain myself out doing analytics, you
Mm-hmm.
know? And
Yeah.
I think that's one of the fear when literally the glucose in my body, my cells are working more, uh, you know, to do
Yeah.
certain math versus the easier way out is patterns. So I'm very good with patterns. I speak many
Yeah.
languages. That comes easy for me.
Yeah.
So with system one, I don't strain enough. With system two, I strain. I literally strain my body and my mind, and
Yeah.
I'm fatigued at the end of it,
Yeah.
right? But that was me. It was a very biased way of looking at world. But I'm introducing a scientific concept here: system one and
Mm-hmm.
system two thinking.
Yeah.
So for those, I'm assuming younger kids are listening to this podcast, right? For those who find calculations draining
Yeah.
mentally,
Mm-hmm.
how would you encourage them to further go on to mathematics and walk the world of abstraction?
So that's a very nice way of putting it. So the way I put it is these calculations that you said, system two, I think of them happening in your working memory. So your working memory has to retrieve all the knowledge it has stored, all the concept it has stored, and bring it forward to this working memory. And then you do these computations. So I cannot tell you that it is not tiring, or I cannot tell you that it's not frustrating. But the idea is that if you sort of think of it as going for a walk in this world of mathematics, so you are, imagine that you're going for a walk within your mind, and you like sort of collect all these apples and oranges in your basket, and then now you have this fruit basket on your table, and now you have to sort of cut and peel. Of course no one likes cutting and peeling things, so that is like, of course it is exhausting, but then you have to remind yourself that you might find something extremely beautiful. So calculations are of course tedious, like our brain does like sort of run away from it. But and also if you don't see yourself, like you're not making any progress, for example. But I think like seeing the patterns itself and collecting all your like concepts is already like a large part of the thing done, and now you just have to like plan and understand what you want to do. So like people, of course I am also a very lazy mathematician.
I
So
like that. Lazy
I'll just
mathematician.
like, I what I would want to just say is that if I can, I given how lazy I am as a mathematician, if I can do it, like everyone can in a
Yeah.
way. So I think, yeah, just if you, if you sort of tell yourself, okay, if you just bring yourself to be interested in something, like
Yeah.
suppose I told you after this tedious multiplication you don't like feel like doing right now, you're going to find something really cool in the end. I think that gives you more motivation for doing it, right? Like suppose you find a really really nice number at the end. So I think the motivation for like going through the tedious calculation bit is that you will find something, or you might find something really cool in the end.
Yeah.
So I think that sort of drives past that
Yeah.
idea of doing something.
Yeah, great discussion there. I
Mm.
like what you said, and this brings me to the next concept, right? We discussed about tedious mathematics and calculation, but it's
Yeah,
it's also about abstraction and thinking and concepts, right? Now,
exactly.
the next
Yeah.
idea: what if AI in the
Hmm.
future could do the calculation for you, just like a
Absolutely.
calculator does a calculation for
Absolutely. Yeah.
345 cross 642? I don't
Yeah.
need to do
Yeah.
that, but I can still be in the abstraction layer
Yeah.
and design higher level concepts. So,
Absolutely.
any signs of AI coming into theoretical
Oh my
physics
God,
and
I am
mathematics?
so passionate about this thing. So, like back in 1930s, 1940s, you had these human calculators, like people who would sit in little rooms and do these like giant calculations by hand.
Like
And
Shakuntala Devi.
exactly. And now we have, so what have, how have we progressed? We still teach children what addition is and what multiplication is, but we don't want them to be able to like multiply large numbers. Of course, in principle they can, as long as they understand what is it that the idea of multiplication is. So I think like AI of course will be much better at than humans at like applying things, or like given a theorem applying it to get
Mm,
some results. But
mm,
what we really really need to improve at is like thinking logically, like how do we come up with proof ideas? How do we come up with new definitions? Like, how do we abstract out the structure from mathematics into these abstract ideas and then sort of condense it and then move forwards? Because from all the things that have been done before, AI can definitely will make fewer mistakes, will not have errors, and it will just compute much better than us. uh, but I think the idea is that we are the thinkers somehow, like the creativity that goes into like finding a proof of a theorem is something which is very human still,
Hmm.
because like coming up with different proof ideas is still a very like creative thing. You struggle, you try this, doesn't work out, you try something else, it doesn't work out, you try some 10th thing and it works out. So I think that is, and you get analogize from all different places, like you see like, okay, this proof worked in that area in this way, maybe I can try to like abstract that idea out and apply it here. So I think, of course, uh there is, so this is a very human activity, and collaborating with different people. So I think more than like telling people a theorem and asking them to apply it over and over again, we have to like tell people a theorem and then discuss for hours how would you prove it. And then in that discussion will lie the real idea of the real proof, and might also lie like new ways of thinking about the proof. So I think the education system should gear more towards like how to come up with proof ideas, like how to come up with algorithms, more than like applying the thing and getting numbers out.
Hmm. Great
Yeah,
reflections. How can mathematics be more human, conceptualizing be more human, come up with proof ideas and algorithms,
yeah,
uh, and be less bogged down about, let's say, hardcore calculations? On your
exactly.
example of early humans performing calculations in
Yeah,
big laboratories before, now you
yeah,
could actually think about higher level concepts.
yeah.
AI doesn't sound that scary after I listen to you that saying that.
Yeah. I
Okay.
think, but I
Uh-huh.
think what is extremely important is that we start having these conversations, like you and
Yeah.
me, and like people who are more important than us, in like really changing, start thinking about changing the way children are taught. Like, what are
Yeah.
they taught? What skills do they acquire? Like, when a little child is understood multiplication, like it's not just the skill of multiplying numbers, it's the idea of what multiplication is trying to capture. Has
Yeah.
that landed home? Because
Hmm.
that is something we don't have access to for an AI. Like, we don't know if AI understands multiplication, but we can ask, do I as a human understand what addition or multiplication is doing, or what
Yeah.
symmetry is? So I think there is this like slight edge that humans have about
Hmm.
like having a like an understanding of a concept. um
Absolutely.
yeah,
Where is that coming from? Intuition, the higher power? That's up for further
exactly.
discussion.
Yeah.
Next question for you, Nivedita.
Hmm.
When you're solving a problem, a
Yeah.
mathematical problem or theoretical physics, and you hit a wall,
Hmm.
how do you tackle it, right? You
Oh
repeatedly,
my
and
god.
PhD is that exercise for next five
Oh
to
god,
six years.
yeah. This
When you
is
hit a
also
roadblock,
something.
how do you manage it?
Hmm. Yeah. So again, this was also something we are never prepared. Like doing my J exam, doing my undergraduate, writing all these exams, I was never prepared for being stuck, like not knowing what to do, which is all that research is really about. So sometimes it's just me and my supervisor, and I write something on the board, and we are both just terribly confused looking at it and being like, oh my god, what is happening? But I think that is like, once you learn to enjoy that, it's not scary anymore. Because what there is, the exercise of like trying to find the truth should be as enjoyable as like having found the truth. So when I get stuck on something, I breathe, tell myself it's okay. The world is not ending if I don't solve this. It's okay. Then go for a walk, come back to the problem, talk to my supervisor, talk to my friends who are also doing maths, talk to non-maths people. Sometimes I just call my dad and he is not done mathematics. I'm be like, Dad, this is not working. Just like talk it out. Make sure that you feel that it's okay. And then one day suddenly it will work out because you have to just keep trying, and one day the idea will strike, and then you'll be like, okay, this is how it is supposed to be. uh, but I think the of course I am like sitting here telling you don't give up. uh, every now and then I'm feel like, oh my god, I should give up, but then the idea is to just keep going.
Yeah, I
And
mean, even
it should be
Einstein used
out.
to chew on a problem, sleep on a problem, and
Yeah,
come back to
sleep
that
on a
with
problem,
newer
go for
ideas.
a walk on a problem,
Yeah,
like just have nice hot chocolate on a problem. Like give yourself the freedom to feel like, okay, right now it's not working and it will eventually work, so just calm down. It's okay.
beautiful,
Yeah.
beautiful. Yeah, the third important wisdom from this conversation here is breathe on the problem.
Yeah.
Hmm.
You have no idea. Like during the day I tell myself at least 50 times, breathe, breathe. It's okay.
I have no
Uh,
idea, Nivedita, about that. Trust me. Well, Sheldon Cooper, he deserves to be sitting on that couch, whatever his place is. He has earned it in
yeah.
theoretical physics. It's a darn, I wouldn't say difficult, right? You got to love what you're doing, and you got to, as you said, the journey is the reward, right? I mean, it's the
Yeah.
quest for truth.
Yeah.
It's not the outcome. I think the world really trains us on the outcome. Show me the
That is,
result. What's the
yeah.
ROI, right?
Yeah.
Job lagegi ki nahi after engineering, right? Like, give me the
Absolutely.
ROI. That's what every Indian parent is telling to their student, right from
Yeah.
start to corporates and companies out there. Show me the
Mhm.
ROI. And here in the beautiful realm of physics and mathematics and science, I would argue, is
Yeah.
that you are on the quest for truth.
Yeah.
You know,
And
yeah,
I'm not saying that it is not scary. Like staying in academia is very scary. You don't
yeah,
know if you'll get a job. You don't have a permanent job. You have years
yeah,
and years of like postdocs, moving countries. It's not an easy thing, but and it's also like take one day at a time. Like I tell myself, like people ask me, do you know where do you want to go for a postdoc? Do you want to stay in academia or not? And I tell myself, it is one day at a time. Like today, this is my problem that I'm working on. I really, really love thinking about it, and I'll think about it. And what
yeah,
comes later, we'll deal with it later. So
yeah,
I think otherwise, it's just so stressful. Like, I don't know if I'll publish 5 things or 20 things. I don't like why, who knows?
yeah,
So I think as long as you're okay, it's also slightly I think I am lucky in a way because my supervisor is very nice, and I think it's very important if you're in academia or if you're a student thinking of applying for a PhD or a master's. It's very important that you find people around you who are kind and who are supportive in this way, because otherwise you can also feel stressed that, oh my god, I need to have these publications before I finish, and that takes a little bit of like the joy of doing things out
mm,
if you're doing it for something else, like for a
mm,
degree or for a publication. I'm not saying that I'm like this, like above and beyond all of these, because I would have to produce results. But I
yeah.
think if you like can detach from this idea for a bit, that makes the process of doing what you're doing slightly more enjoyable.
Always remember that Gita quote we mentioned about earlier.
Yeah, exactly.
And you're living it. Beautiful. All right. So very good discussion so far. I'm sure our listeners, they see the beauty of mathematics here, and somebody who is taking this to the next level through her uh, PhD in Oxford. Now let's go to your childhood, Nivedita. You mentioned so much about your father and the
Yeah.
role he had. Talk to us about your childhood. I think I heard you did not have internet growing up, so that got
No.
me curious.
So
So
my
talk to me about
mom,
your childhood, lack
yeah.
of internet, and your father.
Oh, my mom too. So my mom, to my mom, I would not talk about science or maths, but to my mom, I would talk about feelings and like how school was and what is stressing me. But to my dad, I will talk about all like mathsy things. So my parents, so I grew up in a very small town in Punjab. It's called Hoshiarpur. I spent the first 18 years of my life in the same house, going to the same school. Um, and my mom was an English school teacher, so she used to teach English in a local school. And my father was like a freelance investor, like he was in this stock market or share market. He did history for his masters and then gave up on history. But and I'm the only child. So I think during my childhood, my parents sort of encouraged this idea of like learning for the sake of learning and not learning to get something out of it, not
Hmm.
learning to get good marks, not learning to get like first position in class. So I think this is something that is very, very precious to me, that they really encouraged that I learn for the sake of learning. So of course, if I come back home and say, "Oh my god, I got full marks," or "Oh my god, I got first position," they would be happy, but they would be happier if I said, "Oh, I understood this thing, like this is how it works, and did you know this?" So I think that trade-off is very important. So if you're encouraging learning for the sake of learning, it's much more valuable than like learning for the sake of like achievements or learning for the sake of like getting a prize home, which all follow if you start enjoying learning. So I think that was very important. And of course, I grew up without internet, which I kind of am grateful for, like thinking how like sort of addicted we get to internet and technology these days. So I did not have internet growing up, so if I ever had to do like a project where I did need information, I would go to my dad's friend's house or some place which would have a
Why
computer
did you
on it.
not have internet? Was that a conscious decision by the household?
Yeah, it was a conscious decision my parents. So we did have a desktop at home, but we did not have internet because they thought that whatever I wanted to learn, I could learn from books. So even for like class 10th, my father would like get me like university level books or something which I wouldn't read from cover to cover, but which I could refer to if, in case I wanted an answer to a specific question. So I would have lots of books which my dad again borrowed from his friends, or my mom borrowed from some libraries. So I think it was actually a very wise thing, I would say.
Hmm.
uh, but yeah, that was it. That is how I learned
Got
in
it.
a way.
Got it. Oh, very special. You know, your
Yeah.
dad and mom both are very special. I'm sure
Yeah,
they're watching this, and they had a
yeah,
lot
just
of
say hello.
impact on you.
Yeah.
Uh, and then talk to us about the journey to IIT. How did you prepare for that?
Mm.
And
So
then very important, Oxford, right? Well, so let's also talk
yeah,
about
yeah.
post
So
IIT. How did you decide which university to pick? When Oxford? How did you go about that?
so there are two, so another like two milestone that most Indian students have to like after class 10th, they have to decide whether they're going for like medicine or whether they're going from non-medical degrees. So for my JE like joint entrance exam preparations, I moved to Chandigarh, which is like the closest big city from my hometown, for this like joint entrance exam preparation. And I like did so that was my journey to IIT. Like you get certain rank for in this entrance exam, and you get you sort of choose which of the IITs you want to go in. You, according to your rank, you get this whatever stream you're studying. So that I think like most people sort of have sort planned for them, like okay, some people are going to Kota for studying, some people are going to New Delhi, some people are going to Chandigarh. So those 2 years, I would really like to stress that of course these 2 years are very crucial because they will decide where you end up, but they are not like they should not sort of take your soul out of you in a way. Like you're preparing for the entrance exam, and it's quite unfortunate that it is so competitive, but it should like it you should still remember who you are and what why you are doing this. Like every evening, still go for a walk and still try to do something you really enjoy. Listen to music, or like do something nice, cook a meal, like do things that you enjoy. Because if this, like preparing for this like crazy hard exam, sort of, if it takes life out of you for those 2 years, it's definitely not worth it. So that is something I would want to say for the JE preparation. But once you are in a college where you want to be, then it is like you are in a playground. Then you can explore as much, learn coding if you want. No matter what stream you're in, you can be a civil engineer or a materials engineer or a mechanical or a computer engineer. You just explore all these things. Maybe you're really good at robotics, maybe you're really good at like designing cars, maybe you're really good at, I don't know, like there's so many things to explore. So once you're in your like undergraduate degree, then you just explore, which is what I did. Like I did lots of psychology courses, I did lots of like neuroscience courses. Before all my physics and maths stuff, I actually have a publication in like cognitive neuroscience with a professor at IIT Kanpur. So you just explore and have fun. And so that is like, don't let the J years take your personality out of you, which is something very crucial. Um,
Yeah.
and finally, for the PhD applications, which a lot of students still email me and ask me, like, how does that happen? So what I recommend is, of course, you need to have. So what are a couple of important things? You need to have uh, a great sort of statement of purpose. Like, why do you want to do PhD? If someone says, I want to do PhD so that I can get a job, that's not the right, like that's not the right sentiment to have. Because of course you can do a PhD and get a job after, but that is not the mindset you go into doing a PhD for, because it's like 4 or 5 years of your life that you can't be devoting just so that you can get a job after, because you can still get many jobs before. So you should have a statement of purpose of why you want to do this. Does it really interest you? Then you need to have recommendation letters, which is again very crucial. Be it your course instructors, be it people you have worked with, people you have done some project with. That helps if you have explored many things, because then more people know you, or your work ethic or your interest in the field. So recommendation letters are very important. And then there is just like uh a willingness to sort of explore different, like not be scared of failure. So you know that if you're going to apply to 10 places or 5 places, you might get rejections from a lot of places, even if you're an excellent student. But you still have to like brace yourself and apply, because these people haven't met you, these people don't know who you are, and you're presenting yourself with a CV and a statement of purpose. So just like being mentally prepared for rejections, but still like sort of getting over that fear and still applying. I think, yeah, that is basically it. So I applied to maybe 3 or 4 schools. And another thing I wanted to bring up, which is not usually stressed, is that, of course, if you're coming from, like, if financial like conditions are an issue and all these applications to universities cost a lot of money, so then you can of course write to the admissions office and say that, look, I am very interested, I'm a serious applicant, but I cannot afford to pay this application fee, and they would waive it for you. So I think, like, getting over that hesitation of asking for help, or getting over that hesitation for, and then just not applying, is something that most people or most students are fearful of. So you can just say, I am really interested in working with this professor, and I will make a serious attempt at my application, but the application fee is the only hindrance. Then you just write to the university, and more often than not they will write back to you waiving your application fee, because they do want good candidates to apply. So I think that yeah, that is kind of, that summarizes what goes into like applications for in academia after you have done your undergrad degree.
Excellent, excellent summary there. You made it sound so easy, by the way, but it's not. It's
No.
years of hard work, focus.
Yeah.
Um, and we are very, very proud of you, Nivedita, that you are in Oxford now.
Yeah.
Um, towards the closure of our discussion here, Nivedita,
Mhm.
what do you want to be eventually?
Uh, what do I want to be? Maybe just a kind human. I
Hmm.
think that is more important. I want to be always enjoying what I do, and no matter whether it is in academia or outside, even if it's like teaching like a tiny group of people in a remote area, I just want to be enjoying what I'm doing at any stage of my life, and just be kind, and like always feeling excited about telling anyone who cares about my work. I think that is more important, like that is extremely important. um and yeah, I would have wanted, like a typical Indian child said, I want to make my parents proud. But I'm trying to let go of that, like, like extremely strong desire of like doing everything in my capacity, because I think my parents are just proud if I'm happy and if I'm just doing things I love. So, yeah.
Being kind, is there a mathematical formula to that?
Uh,
I'm wondering that.
I wish, I wish. But I think even in mathematics, it's so important. Like, if there are professors who you can go and ask stupid questions to, who are always ready to explain to you
Hmm.
what this idea is about, I think like kindness is really important. You can be proving unbelievably nice results. If you're not kind enough to
Hmm.
explain it to others, then there is no
Hmm.
value in it. Like, we
Hmm.
as a society, like, work together,
Hmm.
so that kindness is the key, like glue that
Yeah,
is holding everything in
absolutely.
place.
Absolutely. One more question I forgot to ask. Oxford.
Mhm.
Describe, the milieu, the environment in Oxford
Oh my
to our
God. It
international
is
listeners in
it's
India and
like a
abroad.
fairy tale, to be honest.
Okay.
It's really like I pinch myself walking around. I'm like, oh my God, I'm living here. Because it's absolutely beautiful, and the city is very nice. The community is very welcoming, very nice. My department of mathematics and theoretical physics both, this is like, it's very nice, and everything is pretty and beautiful, and people are extremely kind, um, welcoming, and yeah, I've made some really great friends here. I think the best part of studying in Oxford and like living here is that your closest friends can be doing like completely different things. Like, one of my closest friends, she's a lawyer, and one of my other closest friends, she is an archaeologist, and we
Hmm.
talk about our subjects extremely
Wow.
passionately to each
Yeah.
other, and I think that kind of like bringing everybody together, and like living together and working together in their academic
Yeah.
pursuits. I think that is the best part about Oxford.
That is so beautiful. Wow.
Yeah.
Amazing. Okay. With this, we come to the fun part of our conversation, rapid fire questions.
Oh my God. Yeah.
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 Have fun. All
Mhm.
right. Your first question is one thing you miss about India in UK.
My mom's food. I want mom to cook nice dal and roti for me. So yeah, mom's
All
food.
right. Okay. Next one, a great scientist, physicist, or mathematician from India that the world should know about.
Of course, Ramanujan. Like, both me and my father are like big fans of his journey all the way to Cambridge from this little town in south of India. I think the absolute genius of the kind of mathematics he produced. Everyone should like look him up, look at the results, just look at how, again, mathematics comes from your soul or from your heart. So yeah. Uh,
Next one, a great Oxford alumni or alumnus that the world should know about.
oh, there are so
Yeah.
many. Um, who is it? So I think there is a very famous economist in my college, Professor Vijay Joshi, who is from India, and I think he came to Oxford in a ship or something many years ago, all the
Wow.
way from India, and he's a very famous economist. He was, I think, he did his PhD or masters here, and then he became a professor here. I think like people in the Indian community should look him up. Yeah.
All right. All right. The best IIT campus in India?
Kanpur.
I knew the answer.
Yeah, yeah,
Why?
it's we have Nil guys,
All
we
right.
have peacocks, we have lots of friendly dogs, and it's just a beautiful, beautiful campus. Yeah.
All right. Okay. IIT Madras, Bombay, Kharagpur,
I've been to
Guwahati.
Madras.
What's else?
I still prefer Kanpur. uh, yeah.
All right. Excellent. Excellent. All right. Next one. One thing that India's education system should change to produce more higher level mathematician.
Mm, stop. Not stop. Well, like encourage people to do things their way. Like stop putting everybody in the same box and stop expecting the same kind of answers from everyone. Like let children be themselves and let them be expressive of their unique way and appreciate and acknowledge their unique way of like doing things and learning
Hmm.
things.
All right. And I like that. Encourage, but I'm sure this is happening. Um, okay,
Yeah.
last question. Your go-to place for Indian food in Oxford.
Oh, there is this restaurant Curry Door. I absolutely love it. The owners have adopted me as their daughter, so it's like the best food outside of home that I can get. It's called Curry Door. It's near the train station.
All right.
Like lovely
Nivedita's
people,
mom,
lovely
are you
meal.
listening? She's getting Indian food. So she's
um,
awesome. All right. Nivedita, to bring it home, this was a very insightful interview, right? Mathematics, this is the topic that a lot of people get overwhelmed by, but I think, we really touched on mathematics. Why pursue something in science? The importance of loving what you do,
yeah,
the role of parents in educating, like truly educating, learning,
yeah, yeah,
uh, you know, showing the importance of learning to their children,
yeah.
and just being committed one step at a time to what you're doing, and it'll lead to the
Absolutely,
results, right? So with this
absolutely.
all, right, what's the message, closing message, Nivedita, you would like to give to the entire Indian diaspora, folks in India or abroad?
Um, Again, just like try to find joy in whatever you're doing every day and just keep going, like just keep walking in some way on this journey, I think. Yeah, and find pleasure in little beautiful things like looking outside at the moon or looking outside at the stars. I think like not neglecting little pleasures of life, and not being overwhelmed by like work in some way, like yeah.
All right, with that, Nivedita, thank you so much for joining our podcast. Thank you to all the listeners. Bye bye.
Thank you. See you. Bye bye.
All right. It turned